Welcome back. Chapter 4 Correlation and Regression, Section 4.2 Linear Regression and the Coefficient of Determination. Focus points in this section state the least squares criterion. Use sample data to find the equation of the least squares line. Graph the least squares line. Use the least squares line to predict a value of the response variable y for a specified value of the explanatory variable x. So here you are going to predict. Explain the difference between interpolation and extrapolation. Okay, let's see what that means. Explain why extrapolation beyond the sample data range might give results that are misleading or meaningless. Use R squared to determine explained and unexplained variation of the response variable y. All right, in Denali National Park, Alaska, the wolf population is dependent on a large, strong caribou population. In this wild setting, caribou are found in very large herds. The well-being of an entire caribou herd is not threatened by wolves. In fact, it is thought that wolves keep caribou herds strong by helping prevent overpopulation. Can the caribou population be used to predict the size of the wolf population? Let's see. So, let x be a random variable that represents the fall caribou population in hundreds. Let y be a random variable that represents the late winter wolf population in the park. Here is a sample of recent years. X30, Y66, X34, Y79, and so on. All right, so let's plot the scatter diagram. They look positively correlated, right? The points are going up from left to right. They look positively correlated when the x-axis is caribous in hundreds, y is simply number of wolves. Do the data indicate a linear relationship? Can you find an equation for the best fitting line relating x and y? Can you use this relationship to predict the size of the wolf population when you know the size of the caribou population? What fractional part of the variability in y can be associated with the variability in x? What fractional part of the variability in y is not associated with a corresponding variability in x? So quite a bit of thought goes into it. What part of variability means change in y can be associated with change in x? What part change in y is not associated with change in x? All right. So let's see. The first step in answering these questions is to try to express the relationship as a mathematical equation. There are many possible equations, but the simplest and most widely used is the linear equation. Linear equation is equation of a line. Because we will be using this line to predict the y values from the x values, we call x the explanatory, y the response variable. Our job is to find the linear equation that best represents the points of the scatter diagram. In other words, you have these points. You want to draw the right kind of line. Okay. So why not draw this fashion, or just shift it a little bit there and so on and so forth. So we need a criterion for best fitting line. We use least squares criterion. What is the least squares criterion? It states that the line we fit to the data points must be such that sum of the squares of the vertical distances. So here is a point, it's vertical distance to the line. So you just drop down. Here is a point, drop up. Okay, push up, push up, push up, drop down, push up. So straight up or straight down. So that gives you certain distances. You want to take the squares of these vertical distances and sum them up. That sum must be made as small as possible. That is the least squares criterion. To repeat, least squares criterion is the criterion for the best fitting line. It states that the line we fit to the data points must be such that the sum of the squares of the vertical distances from the points to the line be made as small as possible. Least squares criterion, the sum of the squares of the vertical distances from the data points xy to the line is made as small as possible. If D represents the difference between the y coordinate of the data point and the corresponding y coordinate on the line, that's what these D's are. You see, that point corresponds to 20, and so does the point on that line. So x coordinate is the same, is the y coordinate which determines change in height. So what is D? It is the difference in the y coordinates. All right. So if the data point lies above the line, D is positive. Data point is below the line, D is negative. This is why we square it, because you don't want in the sum for the positive to be cancelling the negative. So the sum can be small even if the points are widely spread. Therefore, you square it. That way, you don't get a negative thing to add. So by minimizing the sum of the squares, we are in effect not allowing positive and negative D values to cancel out. It is in this way that we can meet the least squares criterion of minimizing the sum of the squares of the vertical distances between points and the line over all the points in the scatter diagram. So you go through every single point. For every point, take the vertical distance, vertical distance, vertical distance for every point from the line. That sum of those squares of vertical distances must be minimum. Okay, so you're going to do this for all the points. Now, here is a notation, y hat. That small thing is called hat, H-A-T. So, y hat is a plus bx. For the least squares line, a little algebra tells us that b is the slope, a is the y-intercept of the line. Y hat represents the value of the response variable y estimated using the least squares line. Okay, so this y hat belongs here. Okay, so y hat represents the value of the response variable y estimated using least squares line and a given value of the explanatory variable. Techniques of calculus can be applied to show that A and B may be computed using the following procedure. So now all we need are A and B to determine this line y hat. Okay, so what is the procedure to find the equation of the least squares line? Obtain a random sample of n data pairs xy. X is the explanatory, y is the response. The data pairs should have bivariate normal distribution. This means that for a fixed value of x, y values should have normal distribution or at least a mound-shaped and symmetric distribution. And for a fixed value of y, x values should have their own approximately normal distribution. Well, as before in the previous lesson, find summation x, summation y, summation x squared, summation y squared, and summation xy. N is the sample size, number of points you have. So using summation and summation y, you can find the mean summation x over n, summation y over n, that's y bar, all right? So n sample space and all these sums and the means, we are ready to find first b. b is the slope, the number multiplying x is b. The way you find b is using this formula. Once you find b, you can find a using the mean y bar and x bar. Y bar minus bx bar is a. Again, summation x squared means first square then add, whereas summation x, that 2 should be outside, first add and then square. So this is an error, okay, that 2 should be outside. The equation of the least squares, once you have a and b, you now have a line equation which is called the least squares line, is given by this equation. Y hat is the prediction. Okay, we will see what that means. Okay, we'll come to the next example and use prediction, right, to find in our next video. Let's look at this in our next video. Until then.